Well, I think I heard the door close. Okay, go and get started. It's my name. I'm Joe Guadagno. I'm from the lovely state of Arizona in the United States of America. Right now, it is, according to my computer, 1:12 in the morning. So I'm a little half asleep, half awake, but hopefully we'll be able to get through this nice and easy. We're here to talk about TypeScript today. I'm going to kind of give you an introduction to it. We're going to cover some of the basics, things that you need to get started. There's not going to be a lot of slides. We'll just use slides to kind of talk through it. But for 45 of the 50 minutes, we'll be just showing code. You don't need to know about me. So what is TypeScript and why do we need it? TypeScript itself is, we're going to talk about TypeScript, why we need it, and then what we can do with it. So let's start with what it is. TypeScript is essentially a subset of JavaScript. A lot of people say it's JavaScript, but it's not really JavaScript. It's a language that allows you to compile into, or what they use, transpile into a JavaScript language. It allows for a couple of cool things. Probably the biggest and most common feature that everyone loves is the ability to what's called transpile from ECMAScript 6 to ECMAScript 5. What that allows you to do is, with ECMAScript, that's the supported versions of JavaScript in your browser. There's a whole committee that meets and they talk about what's going to be in the language, what's not going to be in the language. And as we know, those committees can take time to agree to things. So what TypeScript allows you to do is to get some of those features ahead of time before they're agreed upon on the implementation. What happens behind the scenes is the TypeScript compiler will take those new features and convert them into modern day JavaScript, as we'll see in a little bit. Like I said, you get a lot of features from today, but the best thing about it is that it's data typed. And it's data typed in theory, in sense. So when you're explicitly typing your code, as we'll see in a little bit, the compiler behind the scenes is doing the checking. The JavaScript that actually gets generated is the same JavaScript that you would have seen before. It's just we're doing a check prior to. So the strong typing comes some great error and compile time and runtime errors that you can catch. It allows you to, or allows the compiler to be able to see what's happening and then tell you if there's code wrong with you, or that you have code that's wrong. It also provides better tooling. With a type-safe language or a strongly typed language, you have the ability to go and do things like autocomplete now and renaming and potentially refactoring and seeing where your code is used throughout. And then you get the nice benefit of clearly expressing what you want, meaning that this object or this variable that I'm creating, I want it to be a number. I don't want it to be a string sometimes and other times, which we'll see. So why TypeScript? Besides all the other benefits I just gave you, it works anywhere in any browser. It just compiles down to native JavaScript that can be read by any of the modern browsers. So that's enough of the PowerPoint. Let's go through and see some of the code. So I'm going to start off with just a new file, and we'll check the size of the screen once we get started. Screen disappeared. Got it? Okay. So you can take any JavaScript file you want and turn it into a TypeScript file just by changing the extension from JS to TS. Here in Visual Studio Code, I'm just going to go and tell it it's TypeScript without having to save the file. What this will get us is all the IntelliSense, autocomplete, compile time checking, and more. And if you don't have Visual Studio Code, you can use Visual Studio. Plus, there's also the TypeScript Playground, which I'll show you towards the end of the talk. So let's start out with the basics. We can go and in the JavaScript world, typically you would do something like x var equals 5. And that pretty much tells us that we want a variable that is going to hold the number 5. That doesn't stop us from doing something like this, x equals 5. So depending on where you are in your code, you can have this change over time. Since I labeled this as TypeScript, you'll see the first thing we get, and hopefully that screen, let me increase the font a little bit here. So hopefully now you'll see that there is an red squiggly line underneath the file. This is telling us that type 5 is not assignable to type of number. TypeScript assumed that it was a number because you initialized it with the number. But if I did something like var x and commented this out, it would allow it to happen. And then if I tried to do x equals 5, it should tell me that there is a problem. The reason why it's not telling me is that there is a problem because I initialized it and it used a generic what's called any, which is the equivalent in C# of like object. It's just you can put anything in here you want. So the better way to do this is to tell TypeScript, give it a hint as to what value or what data type you actually want. So you do that with the colon syntax, and then you give it the data type you want. There are 4 or 5 different data types. We're going to cover most of them throughout the rest of the demo. So here I'm saying, declare me a variable, call it x. I want it to be of the data type number. And here we're going to set it to 5. Once we do that, we get the autocomplete failure saying, hey, this is a number, but you're trying to put a string of 5 into it. So we can fix that by deleting. So right now, it found us the first item, and I can go and assign anything else I want as long as it's a number. They only have numbers. They don't have the difference between int and decimal and float like we have in C#. It's just general numbers off the top. We do have ways, which I'll show you, that you can create shortcuts to declare your intent that you want something to be an integer, but not necessarily be an integer. Another data type that we have is the Boolean. So we do the same thing here. We declare it a Boolean, and then we have the ability to do true or false. There is no 1, 0, yes or no, because again, it's strongly typed. You have a fixed set of keywords that you can use with it. Next data type is string. So we'll do first name equals Joe, and I won't bother you with trying to change it. So we'll just call it a string, and that allows us to only have strings. So if I decide, just like with the others, add a number to it, it won't allow it to have a number because it's only there for a string. It doesn't do any of the conversions like JavaScript does. This prevents you from kind of changing things that you didn't want to. There's also the ability to do arrays. So array is very similar syntax. If you notice, as we start going through these things, the syntax is almost identical to C# in a lot of ways. And the reason for that is the same person that created TypeScript created C#. So I guess he had a wide range of designs. So let's go with the pets. In order to create a variable, you just give it the type, or in order to create an array, you give it the type, and then you put the brackets on the outside. So now I have a string array that we can initialize. And the initialization of a string array is a little bit different. So you put it inside of an array itself, and then each of the items get comma separated in single or double quotes. Once we actually see this, we can look to see what this code looks like in real JavaScript. If we go to the TypeScript Playground, so I'm going to copy this, shift it over here. Now with the TypeScript Playground, it allows you to actually see the code in real time what's happening, and you can actually execute the code here. So I'm just going to go and delete the couple of samples and paste in the URL, which shouldn't happen. So here, if we look, the JavaScript code is exactly the same. There's no real benefit to us using TypeScript initially other than getting the default type checking and stuff. So let's take a little bit bigger look into it. So we're going to create another class or another item. And in this particular case, we're going to introduce the any. The any keyword is a keyword that allows you to kind of put anything you want in there. This is typically used for defining classes or temporary objects that you want. You can do classes in other ways, but this way is usually used for just declaring a model of some sort. So here we have any. This one we use kind of JSON notation for it, so I can do street address. And then set it to 123 Main Street, or main string for that case. And then keep on going with the comma separate list. And this just creates a JavaScript object for us. And let's go back to Visual Studio for now. So we're going to go and take a look at a typical function to talk about how we handle scope inside of it. So let's start off with the function. We're going to do window.onload, and we're going to set that equal to a function. And now we'll do a couple of things. So you'll notice we have a variable x up top on line number 1. We're going to introduce reintroduce the variable x below in a minute. I just want to create a simple number. So we're going to create a new variable and call it z and set it equal to x plus y, just to show that we can still have access to global variables or variables up top versus the bottom. If we look, we did not declare what z was. It inherited, or it assumes that it's a number as a result of the fact that you're adding up two numbers together. So it assumes that you want a number with it. So in theory, I don't have to go and declare it, but to get the true benefits of it, I just want to assign it to a number. So let's do a console.log just to show what we get with x plus y. And we're going to equal it to z. And then we can show the other list. So what's going to happen as we run this, if we would actually run this in the browser, and I probably won't because it'll take extra time with it, but essentially it's going to write console or x plus y equals the number 10 in our particular case, because 5 plus 5 is 10, and it's going to write out the true here. So we still have access to those variables no matter where we are. That stuff hasn't changed. So let's talk about the keyword let. Let is starting to replace the keyword of var in the JavaScript world, because it helps to declare, in more so cases, the actual intent that you want. So instead of just doing var something, we're going to use the keyword let now. So we do let first name, which is a string, equal to Joe. Now this is going to fail because it's trying to create the variable twice within our application. So let's just go back in, delete all these, and see it again. So it's the same syntax, it generates the same code. If we took this code here and went back to the playground, we'd see the only difference is it created a var instead of let, because we're trying to phase out the word var, and until let is actually a valid keyword in JavaScript, it'll just use var for now. So let's do some changes. We got the whole, I still can't do first name equals 5 because it'll fail. So I'm not going to show that. We also have the concept of constants now. We're going to create a constant called iColor and set it to brown. Let's do string. So now if I go and try to change eye color and set it to, let's say I went and had my eyes dyed or got those contact lenses that change colors, as soon as I try to set something equal to it, it disallows, or it says, hey, you have a problem here. If we actually copy this over to JavaScript, it would work, but by adding the keyword constant, you're telling the compiler that you don't want to have this value changed at all, and it should remain the same. In addition to variables and stuff, you can create parameters or assign data types to parameters for functions. So let's say we had this imaginary function f. We can add a variable should initialize and set it to a Boolean, which means we only expect a true or false for this variable. So if I was to try and call it below here with that, it would not work. So let's see what happens with the with using the variable. We're going to create a variable, and we'll do var x number 10. And then we will just return, we're just going to return whatever x is. So if we go and do this nowadays, it will just show us, even if we have a variable x up here, if we don't pass it in, we're going to get one of two things. So if we set the initialize equals to false, we'll end up coming back with a NaN or not a number, or be undefined because we didn't initialize it. We'll also get a failure because x is not recognized at all in this context because it was declared on this line and not within here. So if we went and did f true, we end up getting 10 back, and if we do f false, we end up getting NaN or not a real number. Let's take a look at some constants now. We have the ability also, in addition to constants, to create enumerations now too. Enumerations is the first one of the data types that are offered that will actually have different code written for it when it comes down to the JavaScript part. So let's take a look. We've already seen a constant, so we're going to do a non-constant gender. So forgive me for not putting every other combination. We're going to just stick with male and female for now. So I look at this. If I try to access the non-constant, I can, well, actually, let me create the other one also first. My little spelling thing tells me I made a spelling mistake. Okay, so there's two differences between this. So we take a look at the non-constant one. This one I can actually add to. I want to do lowercase so that we can see it. Apologize for the constant typing. It's a brand new keyboard, so I'm kind of getting used to where all the letters are. So if we look here, we can now assign it to that variable, non-constant, or pick that type. As soon as I hit the dot, I get one of two different choices. I can choose female or male in that case. And if I go to the other one, and we'll do constant gender, we'll get the same selections. The only difference is, you notice here it also has on the IntelliSense side what the value is of that. And it turns out it becomes a zero-based array, which we'll see in a couple of seconds. Let's just take a look at this code and see what the difference is when you go into the JavaScript side of it. So let's go and replace that. You notice what it did with the non-constant gender, which is this section right here. Zoom in a little bit on it. You'll notice that it actually created a function that returns a number based on an array. So it created an array that has non-constant gender, male, which was the text that I typed in for the first enum, and female, and then returns a 1 or 0 based on it. For the constant gender, it only looked at the number for it. So that allows us to go and change it as we want. So like I said, this is the first one that has lots of differences between them. So now we're going to take a look at designing a class. And to save you from having to watch me type, we're going to use the class definition that's on this TypeScript page. So a couple of quick things about this page before we move on to class definitions is this is where you can go to download the latest version of TypeScript, or you can go to NPM, but this tells you when there's newer versions. It's also quick start guides that tell you how, depending on what language you want to use with or what framework you want to use it for, how you can go about doing that. Then there's a documentation page, which I miraculously went offline. There's a documentation page which shows you everything you need to know about TypeScript. So all the samples that I was showing you, you can find on there. It will go through in a little bit more detail than I did to explain how each of them works and how you can start tying them together. So let's take a look at using classes. Oh, I got to change it because I modified the code and the internet went down. Pardon me for a second. If it doesn't work, I have a backup copy of it so we can get to it. There it goes. So we're going to see we created a class called a greeter. And we're going to kind of go line by line just to show the differences between them and why you would prefer to use the TypeScript way of doing things. So here you see we're creating a class, and on line 2, this class has a greeting, which is a string. Creating a constructor with that to also take in that string and set what the greeting is. And then on line 6, we're creating a method or a function to say hello, whatever the greeting is. So we look at the first 9 lines here. It's pretty much the same 9 lines here, except for the only real difference is when you're creating the class, it creates a function for you and then the prototype. I'm not sure with you, ladies and gentlemen, but I always forget how to do the prototype pattern within JavaScript. So this way, at least for me, makes it a lot easier. You don't really see a lot in the number of lines of code reduced yet. as we start building this class out a little bit more, you'll see how it actually reduces your code and makes it easier for you to follow along with us. So on line 11, we're creating a new greeter. So it looks very C#-ish, like let greeter equals new greeter with the word world. So this is our typical hello world. And then we are going to create a JavaScript button or HTML button inside of here just for us to call it. So we go and take a look at it. One of the cool things about this is you can hit run. It generates a page for you, or it actually runs that JavaScript code, and we'll see that we get a message saying, hello, world. And I just met my requirements for presenting because I did a Hello World demo, so I'm good to go for the rest of the talk. So as you see, the code itself is not much different. It's pretty much the same thing we did, but to me, it looks a lot cleaner than remembering to close these braces, because how many times do we have a developer or even ourselves that deleted this space on accident or realized we didn't have enough of them? When you get the compiler behind you, it helps make things a lot easier on us and spend a lot less time trying to figure out what went wrong. Next thing up, we're going to talk about inheritance. This one's a lot bigger, so it's a lot different than what I want to explain. So we're going to show you another one that I have. So we're going to come back to here, and I'm just going to copy and paste out the code, and we will walk through the code together. So general premise behind this is we are going to be building out a car shop, so to speak, or the ability to produce cars. So we go down to the very beginning. Oh, I forgot to remove the existing one. So we're going to go to the very beginning and see that we're declaring an interface for our car. Car has a couple of different pieces to it. So we're going to start off with the engine. The engine has a start and stop method, which in our case is a callback that takes in a start it and the engine type, and then ultimately returns nothing. I'll explain that, and then we're going to flip over to the other side and look to see how we actually implemented those interfaces. Then we have the I auto options, which indicates the price, the type of engine, where this car is, the make, model, and year of it. And then we're going to have one additional for sedans that's going to indicate the number of doors and whether it's all-wheel drive. So let's take a look at lines 1 through 21 on the other side. So we start looking here. We see that this is the initial declaration of trying to build out the interface. So the interface itself is not here, but it's building out the infrastructure or the generic object that's going to be used for us to store the interfaces, because there's really no concept of interfaces in JavaScript. TypeScript allows us to add that into it through a lot of behind the scenes, quote unquote, magic. So if we look at line 14 actually declares a variable called interfaces, which matches what our namespace interfaces is on line 2. And then it starts to create them all. So if we look at var engine, you'll see what it really does is creates a class called engine, which is somewhere down here. And actually, we didn't even talk about that yet. But the interfaces are not actually defined anywhere yet. They don't get defined at all, but TypeScript kind of does the compile time checking when you're building the code out to say this belongs with that class, or this has to implement that, and it does all that type checking. But behind the scenes in JavaScript, you don't see any of that code. That's why we don't see anything from lines 1 through 21 here. What we're actually starting to see is the building out of the class. So you see on line 23 on the left-hand side, we have the exporting of a class. The export is a keyword that makes it public in the C# world. And we tell it that it implements an iEngine. As a result, we get the constructor that was part of the interface, as well as the start and stops that are in there. So on the right-hand side, it creates a class like we saw before with using the prototypes. So far, it really hasn't bought us anything. What it has bought us from a developer standpoint is now if I change this or mistype it, you'll notice that whether I'm in Visual Studio or here, I get a couple of red dots on the side, as well as the keyword engine started to become red with squiggly lines. And if we hover over it, it says the property start is missing in type engine because our engine was declared to have a start and stop as part of the interface. So we get that compile time checking also. And that holds true with a lot of pieces of this. So let's go take a look through the next one down. See, we're going to look at the auto class and just compare them to here. The auto class is a lot bigger. It kind of takes all the interfaces together to make one big car, so to speak. So here we have the private base price and then the engine, and we're telling the engine is of type iEngine. So again, we're going to get that safety checks across the board and then a bunch of other properties. And I did not show the syntax. So we're going to come back to the syntax in a second. So if you go to add accessories on the car, which is a prototype right here, this tells us pretty much take any accessory and add it to the list. On the right side, does a bunch of type checking as far as whether the argument length is there or how far it is. This way it knows to kind of loop through all those. So you'll see, hopefully, that there's not much difference between the two, but TypeScript allows you, the benefits in it are the ability to do a lot of the type checking, a lot of the debugging for us, so we don't have to go through and add a bunch of console.write lines throughout our code. And it helps to make a little bit clearer code, at least in my opinion. This one's actually a really cool example. If you have time later on today when you go home or you're bored, come back to Building Tracer. It's a couple hundred lines of code, but it builds out this really cool website that allows you to you see multicolored lines like the old Windows 3.1 3D pipes. Let's go back to the code. There's one or two other things I want to show when it comes to methods, which I don't have on me. So one feature we are able to do is when we create functions, so let's say I have a function, we're going to call it log because I want to overwrite the log. We're going to ask for, actually no, let's do addition. So before we had a function that did two numbers. So let's do x as a number and then y as a number. And then we're just going to return x plus y. So there's nothing special with this item right now. Let's say we wanted to add in additional logging to this. So we're going to add a, let's call it message, give it a string, and now we can take here, not that we would ever do this, but this is just a demo. Console.log message plus, and then we'll do plus x plus y. Actually, let's do x plus y up here. Var z. So we're going to do message plus space plus z. And the reason why we're doing this is just to show what some of the properties we have and things we can do with that. So if we did add here 5 plus, let's call it result, we'd expect to see when this runs that in the console it's going to print out result, colon, space, and then 10. Let's say we decided to add this method in after we had a bunch of others, meaning, or after we had other code that used add and we wanted to make this optional. Well, there's a couple different ways to make it optional. If you add the $sign to it afterwards, it becomes optional. So now I can do add 5, 5, and that compiles because that's a legitimate item. But what happens when it comes down to here, it's going to print out a null message because message is undefined right now. If you want to provide a default value, you can do that by adding the equals at the end of it and then removing the question mark. Now it becomes optional and you have a default value for it. So it will, in this case, both, if you call it on the top, it'll have the lowercase result with the colon, space, and then the amount, whereas on line 3, we'll call it with the word result, no space, or you'll get a space from here, and then the amount at the end. So you have the ability to go and add or the ability to create optional parameters or make every parameter required now. The code behind the scenes for this is a little bit different because it does some checking for it. So if we go back here and look at our example, here it just adds in line 1 that says if message was not passed, or we don't have that parameter, because within JavaScript you don't have to pass in parameters. If it's not there, we default it to result. If we take out that default, just so you can see what the difference is, and turn this one into a $sign and remove the default, the code looks slightly different. It's actually the same exact code. So you don't really need to do anything extra because you can have optional parameters, but at least the other way, when you do it this way, it's explicit so the compiler can catch it if we need. There's also the ability to do parameter arrays. Let's say we wanted to have this add method take in one or more arguments and just keep adding them together. We're going to do that by changing this argument up a little bit. So I'm going to do a new add. So let's do function add better. So we'll start with the message first on this one, and we will always make it required in our particular case. Then we need to add in something called a parameter array to it. And to do that, if I get the syntax correctly, it should be brackets with 3 dots, or just 3 dots. Nope. They go in front of us. Thank you. So what that gives us is the ability to make this an unlimited array of numbers, and we can just walk through adding in those numbers through a typical for I loop going across. Let's see. Did I cover everything else? Okay. So let's see what the internet is back up. We can go through and take a look at the documentation just to do a quick explanation of it. We're not going to walk through all of it. There's two things that you really want to look at when you're just getting started. The tutorials, they'll literally walk you through the hello world and all the other different options there are. And then the handbook. The handbook gets updated every time a new version comes out, and it goes through and talks through all the different data types, how to create classes, how to use generics, how to use some of the newer features that were introduced like tuples recently, decorators. You can kind of go through. There's a lot more than what I covered. I just covered the initial surface of what there is, and then you can come back here for that. Another thing to look at is the Connect. Connect has different ways for you to interact or learn about TypeScript. It talks about the GitHub page, their Twitter handle, but the more important part is the definitely typed. So what definitely typed is it provides a lot of TypeScript, for lack of a better word, help files or definition files for lots of popular frameworks. So if you're working in Angular, or working in Vue, or working with Joe's latest, greatest JavaScript framework, you can include these definitely type files. And what it does is it actually builds up the IntelliSense for you. So the authors of these frameworks created these type files to help make it easier while you're executing without having to know the entire framework that it's working on. And can give an example once this pops up. But essentially, you'd want to go to definitely type if you're working with any public JavaScript framework. I think there's something like 1,200 different frameworks that are supported, and they provide you with all that IntelliSense and all the types that are supported. So if there's their own custom classes, it'll have the class definitions with any IntelliSense kind of comments to them. So check that out when you get back. Again, you can just go to typescriptlang.org for all of that. And that's about it for me. I'm going to bring up my contact information. If you have any questions, feel free to reach out. I'll be wandering around all day today. It's my name and contact information. If you also want the PowerPoints for this, I'm not sure if they're doing it at the end of the talks, but if you go to my site there below, you can get the downloads of the PowerPoints and all the source files for what I did. Thank you for coming. Enjoy the rest of the stay here, or the rest of the conference.